Okay, so next, the C1. C. Okay, we have a xy solid where the limit of x is constant, -2 to 2, and then y is a function. We have negative square root of 4 minus x squared, plus minus, okay? Okay, so now looks like the function here is similar to the question A, where we have a circle. So you have x squared, y squared equal to 4. So we have a circle, radius 2, centered at the origin on y-x plane. Okay, so now we want to know what is the area need to be shaded. So we know that here we have x constant. So we have to provide the vertical line. So x is in the negative and positive part. And similarly, so the lower bound of y is negative part and the upper bound is positive part of circle. So meaning that we have a complete region circle. So from the region, we can get the limit of theta straight away, where the theta is 0 to 2 pi. Okay, now we want to look at the solid looks like, where we have to refer to the limit of z provided here. So z lower bound is negative square root of 4 minus x squared minus y squared, and the other one, the top one, positive square root. And if you can see both of the equations here, then this will give you the z squared plus x squared plus y squared equal to 4, where this one is a sphere with radius 2. So we have plus minus z, meaning that we have a full sphere with radius 2. This one. And we have this one. And we have this radius 2 on xyz plane. XYZ plane. Okay. And the region, where is your region? So the region is on xy plane. It is a circle with radius 2. So then we can see here that our solid is a full sphere. So now we have to integrate this in a spherical coordinate, where, as we can see here, our integral is 1. So meaning that 1 in a spherical also 1. So we have to use a dv. In spherical is rho square sine phi d rho d phi d theta. The theta is 0 to 2 pi. Okay, so now about your rho. Your rho is from your solid here, which is, it is a sphere with radius 2. So how can you determine the limit of rho? So you just draw a many lines, and the smallest rho that you can see, it's starting at the rho 0, which is the origin. Okay, and end up they will touch the surface of the hemisphere given by rho equal to 2. Okay, and then how about the phi? The phi, okay, so the phi, as I mentioned before, it is about the, just like an umbrella, but for the umbrella, the largest phi, the possible phi that can have for umbrella, I'm talking about the umbrella, is just 90 degree, right? 90 degree. You open the umbrella wider. So this is your umbrella, which is part of the cone. And okay, this one maybe you have 45 degree, pi over 4. And when you open it wider, so when you open it wider, so it can be 90 degree, or it can be, so maybe I draw. So this is the axis positive, and this one is the axis negative. positive, negative. Okay, so now I'm talking about the way you open up the file. So the file you open for this particular angle, or this particular angle, or this particular angle, or you can have this particular angle where this is the angle. Okay, or you can have, so for under other line, so you can have this particular angle. So for this angle, so this one should be more than 90 degree, and you have a larger angle. So, and it's become, if I draw another line, and another line, and another line, and approaching to the z-axis negative. Okay, so as you can see here, for this one, this phi becomes larger and larger. Okay, it's become larger and larger, and approaching to phi equal to what? Phi equal to 180 degree. So as I mentioned before, if you have a complete sphere, so your phi, sorry, this is theta, so your phi is pi. Okay, but if you have hemisphere, so your phi is pi over 2. And if you want to have a cone, so your cone, the standard cone, normally smaller than 90 degree. Okay. So in this case, since we have a complete sphere, so our phi is from 0, where 0 is actually z-axis positive. Z-axis positive. Okay. So you didn't open yet your umbrella, and it's become wider and wider and wider and wider, and to get a complete sphere, so your phi here is equal to pi, and this one pi equal to 0. So 0 to pi. Okay, so then when we plug in, so the phi 0 to pi, and your rho is just now 0 to 2. Okay, so now from now on, if you have your solid is a complete sphere, so your rho is always 0, so not rho, but your phi here always 0 to pi, and your theta is, you have a complete circle, right? And your theta is only 0 to 2 pi. This is for only the sphere, a complete sphere centered at the origin. There is no statement about the first octant or third octant or fourth octant. Okay, so just a complete sphere. So this is the angle that you have to have, where your phi is 0 to pi and your theta is 0 to 2 pi. But your rho depends on the size of your sphere. Okay, so now you have to complete this triple integral where you want to evaluate this sphere. Okay, so when you okay, I rewrite that. Okay, so this is the integration, triple integral using spherical in a Cartesian coordinate, but you have to evaluate in spherical coordinate, and then we have this particular limit. As we know, if you can see here, this is triple integral, and the integral is 1. What does this mean? What are actually you are computing? So we go back with our the general triple integral, and the integral is 1 dv. So this one is dv, right? So this one is actually volume. So this question is actually asking for finding the volume of the solid. So the solid that we have for this question is a sphere with radius 2. So then we want to compute the volume of this sphere, of the sphere given in spherical, and the answer is 32 pi over 3. So please find this yourself, evaluate the triple integral yourself. Okay, so we got that the volume where the evaluation of this particular triple integral will give you this result, which is it is actually volume. Okay, so if we relate with the formula of volume using the form, if we relate the formula of finding the volume, so we know that the formula to finding the volume of sphere is given by pi over 3, 4 over 3 pi r squared, right? R means the radius of the sphere. So now we plug in rho is 3, rho cube, and our rho is 2. So we got 8, right? So 8 multiplied by 4, you got 32 over 3 pi, and the answer is the same. Okay, so this one is using the standard formula that you have learned when before you came to UTM, right? In your school time, you want to evaluate the volume of sphere, and this is the formula. But now, you know, using the triple integral, you will get the same answer. Okay? Okay, regarding the application of the triple integral in sphere, is the same as you have seen in the cylindrical coordinate, where you can evaluate the volume, which means that, as I mentioned for this particular example, so when your integrand is 1 dV, so you are computing the volume. Doesn't matter whether you are using Cartesian, or whether you are using cylindrical, or whether you are using spherical. So the physical meaning of this particular integration, triple integral, and the integrand is 1, meaning that you are computing the volume. Okay, and now how can you have rho squared sine phi? So rho squared sine phi is not the integrand. Actually, the integrand is only 1, but as we know that the dv for spherical coordinate, you have to add this one. Okay, rho squared sine phi. I didn't show it how can we got that. Actually from this one, but I didn't explain here. So because we just want to use them, so I didn't explain. Okay, so we will look at another few examples regarding the application of the spherical coordinate.